So good morning to one and all. How are you all? So my name is D.V. Subbarao, working at TGTWREIS, Huzunare. So today we are going to learn an important topic in our Maths 2B. Okay, before going to start the class, I would like to ask one small question to you. So observe the board carefully. So observe the two integrals. Do you know integration? Yes, in our previous chapter we have learned indefinite integration, no? So this is integration sign. So first one is integration and second one is also an integration. So what is the difference between these two integrals? What did you observe? So in the first integration we don't have any value above and below the integration sign, right? In the second integration we have two values, 0 and 1, above and below the integration sign. That is the main difference between these two integrals. So what do you call the first type of integrals? These are indefinite integrals. So we have learned how to evaluate indefinite integrals in our previous chapter, right? Okay, so what do you call this type of integrals? This type of integrals are called definite integrals. Today we are going to learn definite integrals. So what is our topic? Our topic is definite integrals. So before before entering into the topic, so I want to clear one thing. Today we are going to learn the definition of definite integral and some properties of definite integrals, and we will do some problems on properties. Okay, we are covering these topics only today. Okay, first, what is a definite integral? So listen carefully, definite integral definition is very important. So f of x is a function, f of x is a real valued function, f of x is a real valued function. So defined on closed interval a comma b. So it must be defined in that closed interval a comma b, and integral f of x dx is equal to f of x. F of b minus f of a is called definite integral of f of x over the closed interval a comma b. It is denoted by integral a to b f of x dx. So from this we can write integral a to b f of x dx is equal to f of b minus f of a. So here a is called lower limit and b is called upper limit. So a is called the lower limit of the integration and b is called the upper limit of the integration. So once again listen the definition of definite integral. So f of x is a real valued function in the closed interval a comma b. So the function must be defined in that interval. And already we know, we have learnt in indefinite integration, integral f of x dx is equal to capital F of x plus c, and f of b minus f of a is called definite integral of f of x over closed interval a comma b, and it is denoted by integral a to b f of x dx. So from this we can write integral a to b f of x dx is equal to f of b minus f of a. So integral 0 to 1 by 1 plus x square dx. This is our first problem. So I will solve this problem later. So before going to solve this, I will ask you one question. So can we find out integration of integral minus 1 to plus 1 by x dx? Is it possible to integrate integral minus 1 to plus 1 by x dx? Yes or no? So before going to find, first we have to check, is the function defined in the interval minus 1 to plus 1? So the integration is not defined here. Why? Because 1 by x is not defined 1 by x is not defined in the interval minus 1 to plus 1. 1 by at 0, 1 by x not possible. No, the value of 1 by x is in infinity, so we cannot find integration of minus 1 to plus 1 by x dx. Okay, sir, we have the formula integration 1 by x. No, why can't we apply? So try it, no problem. So I will do here. So we have the formula integral 1 by x dx is equal to log x. We know the formula. We have learnt this formula in indefinite integration. I am trying to apply this formula. Integral minus 1 to plus 1 minus 1 to plus 1 1 by x dx. So 1 by x integration is log x. So upper limit and lower limit. As per definition, f of b minus f of a. So first we have to substitute upper limit in the answer and next lower limit, and then we have to subtract. Log 1 minus log of minus 1. So we know log 1 value is 0, right? Log 1 is 0. But what about log minus 1? Is it defined? So we cannot define a log of a negative value. So integration does not exist for integral minus 1 to plus 1 by x dx. Why? Because 1 by x is not defined at x is equal to 0. 0 is a part of the interval minus 1 to plus 1. Okay, sir, in indefinite integration we have plus c, no? What about that c in definite integration? So integral a to b f of x dx. Here the formula is what? F of b minus f of a. Okay. So integral f of x dx is equal to f of x plus c as per our indefinite integration. So what is the integration of f of x here? Capital F of x plus c. Now I am applying the upper limit and lower limit. First I will substitute upper limit and then I will substitute the lower limit, and after I will subtract. F of b is equal to f of b plus c. So f of b plus c, this is upper limit, and I am substituting lower limit. f of a plus c, f of b plus c minus f of a minus into plus minus minus plus c minus c get cancelled. So f of b minus f of a. So that's why forget about c in definite integrals, nothing to worry about c. So up to this, is it clear? Okay. So I will recall definite integral once. So f of x is a real valued function which is defined on the closed interval a comma b, and integral f of x dx is equal to capital F of x plus c. So f of b minus f of a is called definite integral of f of x over the interval a comma b. It is denoted by integral a to b f of x dx. So from this we can write integral a to b f of x dx is equal to f of b minus f of a. Now I will do small problems by using indefinite integration formulas. Already we know indefinite integration formulas, no? I will write some of the formulas. Integral 1 by x dx is equal to log x plus c. Integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. So integral sin x minus cos x plus c. Integral secant square x dx is equal to tan x plus c. So we have learnt these formulas in our indefinite integration. Right? Now I am using those formulas now to solve the problems in definite integration. So I am taking the first problem which I have written on the board. Integral 0 to 1, 1 by 1 plus x square dx. Now I am going to find a definite integration of 1 by 1 plus x square dx. Now I am going to evaluate integral 0 to 1, 1 by 1 plus x square dx. So already we have formula in our indefinite integration. Integral 1 by 1 plus x square dx is equal to tan inverse x plus c. Is it right? Yes or no? Okay. So now I am using that formula to evaluate this definite integral. So integral 1 by 1 plus x square is equal to tan inverse plus c, tan inverse x plus c. I already told you. So forget about that c. So here the lower limit is 0, upper limit is 1. First we have to substitute upper limit. So upper limit is 1. In place of x I am substituting 1. Tan inverse of 1 minus, and next I am substituting lower limit, tan inverse of 0. So from the tan table, where we will get 1? Tan pi by 4. Tan pi by 4 is equal to 1. So tan inverse of tan pi by 4 minus tan inverse of 0. In tan table, where we can get 0? Tan 0. Tan 0 is 0. So tan and tan inverse get cancelled, pi by 4 minus tan and tan inverse get cancelled, 0. So the answer is pi by 4. This is the simple integration. So I have here I used the definition of definite integral. What I did here, so I have taken the formula of integral 1 by 1 plus x square. After that I substituted upper limit and the lower limit and I subtracted. So I got the answer. Is it clear? I will do one more small problem. Here I used the definition of definite integral. What I did here, so I have taken the formula of integral 1 by 1 plus x square. Okay, next problem is, next I am going to evaluate integral 0 to 1 x square dx. So here the function is x square. So what is the formula for integration of x square? We have a formula, integral x power n. Integral x power n is equal to x power n plus 1 by n plus 1 plus c. right? Here I am using this formula to evaluate this definite integral. So x square, so x to the power of 2 plus 1 by 2 plus 1. So limits 0 to 1. First I am substituting the upper limit. Okay, before substituting upper limit, I am simplifying it. X cube by 3, 0 to 1. Now first I am substituting upper limit in place of x. 1 cube by 3 minus, next I am substituting lower limit 0 cube by 3. So 1 cube means 1 by 3, 0 by something 0. So answer is 1 by 3. So like this we can solve many definite integrals by using indefinite formulas. So we can use the procedures also like substitution method. We have different method. We have learnt different methods in integration now. So we can use those methods here. Next step, fundamental theorem of integral calculus. So if f of x is integrable in the closed interval a comma b, f of x is integrable in closed interval a comma b, there exists a function f dash is equal to f. There exists a differentiable function f dash is equal to f, then integral a to b f of x dx is equal to f of b minus f of a. So just remember this theorem. So already we have discussed it now. So now I am going to explain small properties of definite integration. So first one, integral a to b f of x dx is equal to minus integral b to a f of x dx. So what did you observe here? So in the left hand side the limits are a to b. So lower limit is a, upper limit is b. In the right hand side the lower limit is b and upper limit is a. What happened here? The limits are interchanged now. So whenever you want to interchange the limits, so just keep the negative sign. I will prove it. Listen, integral a to b f of x dx is equal to f of b minus f of a. By the definition of definite integral or fundamental theorem of integral calculus, we can write integral a to b f of x dx equal to f of b minus f of a. Now I am taking minus common. I am taking minus common. So can I write like this? F of a minus f of b. So minus of. So by the definition of definite integral, we can write it as integral b to a f of x dx. So in some problems, we can get the lower limit is greater than the upper limit. At that time, we can use this property. So suppose if you get like this, integral minus 2 to suppose if you get like this 2 to minus 2 1 by okay like x square plus 1 something dx. This is the integral. So here the lower limit is 2 and upper limit is minus 2. So here the lower limit is greater than the upper limit now. So we have to change it. So to change it, what we have to do? We have to keep the negative sign and we can interchange the limits. Minus 2 to 2 1 by x square plus 1 dx. Like this we can like this we can use this property. Is it clear to everyone? Okay. Moving to the second property. integral a to b f of x dx integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. So here c is lies between a and b. So c is the value, any value you can take between the interval a and b. So we can write like this, integral a to b f of x dx can be written as integral a to c f of x dx plus integral c to b f of x dx. Now I am going to prove this. So for proving this I am taking RHS first. So this is the RHS, integral a to c f of x dx plus integral c to b f of x dx. So from the definition of definite integral, what we can write, integral a to c f of x dx means f of c minus f of a, right? Plus, by the definition, what we can write, integral c to b f of x dx means f of b minus f of c. So f of c minus f of a plus f of b minus f of c plus f of c minus f of c get cancelled. So we can write f of b minus f of a. So can we write this as integral a to b f of x dx? Yes or no? Is it proved? So LHS is equal to RHS. So if C is any point in the given interval, we can write, we can split the integral like this. Integral a to c f of x dx plus integral c to b f of x dx. So I will give you one example. So minus 1 to plus 1 f of x dx. So here the interval is minus 1 to plus 1. So I am taking the 0. Is it 0 lies between minus 1 and plus 1? Yes. So I am splitting the interval like this. Minus 1 to 0 f of x dx plus integral 0 to 1 f of x dx. Okay. Whenever we need, we can use this property. Is it clear? Okay. And the third one, integral a to b f of x dx is equal to integral a to b f of t dt. So here what is the difference? In the first integration the variable is x, in the second integration the variable is t, but both the integrations are same. Why? Because so integral a to b f of x dx, by the definition what we can write, f of b minus f of a. So the left hand side integration value is f of b minus f of a, and moving to the right hand side integration, a to b f of t dt is also equal to f of b minus f of a. So here the both side, so the right hand side values are equal now. So from this we can write directly integral a to b f of x dx is equal to integral a to b f of t dt. So these are the three properties of definite integrals. Now I am going to explain some problems based on these properties. Not only these properties, so we can use indefinite integration formulas and indefinite integration methods. So simply we are going to evaluate definite integrals. So these questions are important for IPE and EMCET and etc. etc. So the first question is integral 0 to 1 x square by 1 plus x square dx. So this is the question. So tell me, is there any formula which is suitable to solve this problem? Actually, we don't have any formula here. So what we have to do? Integral 0 to 1 x square plus 1 by x square dx. So to evaluate this, I am adding plus 1, adding and subtracting 1 to the numerator. 1 plus x square minus 1 by 1 plus x square. So what I did here, I have added and subtracted 1 from the numerator. So integral 0 to 1. 1 plus x square minus 1 by 1 plus x square. So I am writing like this, 1 plus x square so if a plus b by c is there, can we write a plus b by c as a by c plus b by c? Yes or no? We can write no. So similarly, I am separating these two also. 1 plus x square by 1 plus x square minus 1 by 1 plus x square dx. So 1 plus x square, 1 plus x square get cancelled. Integral 0 to 1, 1 minus 1 by 1 plus x square dx. Now integration properties. So if addition is there between two functions or subtraction is there, we can separate the integration. Integral 0 to 1, 1 dx minus integral 0 to 1, 1 by 1 plus x square dx. So already we have a formula. Integral 1 means, integral 1 dx means x plus c. Integral 1 by 1 plus x square dx means tan inverse x plus c. Yes or no? In indefinite integrations we have standard formulas, no? From those formulas we can write directly integral 1 dx as x and integral 1 by 1 plus x square dx as tan inverse x. Now substitute upper limits and lower, substitute the limits. Here I am doing, so 1 minus 0 minus of tan inverse of 1 minus tan inverse of 0. So 1 minus 0 means 1 minus tan inverse of, just now I told you 1 means tan pi by 4. Tan inverse of 0 means we can write tan 0. Tan inverse get cancelled, tan inverse get cancelled. So the final answer is 1 minus pi by 4. This problem is important for IPE. So intermediate public examination, you will get this type of problems. Okay, is it clear? So once again I am explaining the problem. Listen, here the problem is integral 0 to 1 x square by 1 plus x square dx. Actually here we cannot use any direct formula. That's why what I did here, I have added and subtracted 1 to the numerator. So 1 plus x square minus 1 by 1 plus x square, and then after I splitted a 1 plus x square by 1 plus x square minus 1 by 1 plus x square. So 1 plus x square, 1 plus x square get cancelled. Here we got 1 minus 1 by 1 plus x square. From the indefinite integration formula, we can write integral 1 dx as x, integral 1 by 1 plus x square as tan inverse x, and after substituting the limits, we can get 1 minus pi by 4. So this is the answer. This problem is important for IPE exam. So moving to the second problem, integral 0 to pi by 4 integral 0 to pi by 4 1 by 1 plus sin x dx. So I have taken this time I have taken trigonometric function. So 1 plus sin x is there. So 0 to pi by 4, 1 by 1 plus sin x. So we don't have any formula directly. So what we need to do means, here we have to rationalize the denominator, rationalize the function 1 plus sin x. So I am multiplying and dividing with 1 minus sin x. Integral 0 to pi by 4, 1 minus sin x by a plus b into a minus b. A plus b into a minus b is equal to a square minus b square. 1 square minus sin square x dx. Integral 0 to pi by 4, 1 minus sin x by 1 minus sin square x dx. 1 minus sin square x is equal to what? 1 minus sin square x is equal to cos square x. So we have trigonometric identities now. What is the first identity? Cos square x plus sin square x is equal to 1. From that I have written 1 minus sin square x is equal to cos square x. I am using this formula now. Integral 0 to pi by 4, 1 minus sin x by 1 minus sin square x means cos square x. Now I am splitting the integration. Integral 0 to pi by 4, 1 by cos square x minus sin x by cos square x dx. 1 by cos square x means 1 by cos square x can be written as secant square x, no? 0 to pi by 4 secant square x dx minus integral 0 to pi by 4 sin x by cos square x. Sin x by cos square x can be write like this: sin x by cos x into 1 by cos x, sin x into 1 sin x, cos x into cos x, cos square x. So sin x by cos x means tan x, 1 by cos x means secant x. So in place of this, I am writing tan x into secant x or secant x into tan x, your wish. So we have the formula. Yes or no? In indefinite integration, we have clear formula for secant square x and secant x tan x. So what is the integration of, what is the formula for integral secant square x dx? Integral secant square x dx is equal to tan x plus c. Integral secant x into tan x dx is equal to secant x. So these are the formulas, no? So forget about c. So integral secant square x dx means we can write tan x. Integral secant x tan x dx means we can write secant x. Tan x 0 to pi by 4 minus secant x 0 to pi by 4. Now substitute limits. Tan pi by 4 minus tan 0 minus secant pi by 4 minus secant 0. From the tan table, tan 45 degrees means 1. Secant 45 means root 2. Tan pi by 4 means tan 45. Tan 45 is 1. Tan 0 is 0. Minus secant pi by 4. Secant pi by 4 is equal to root 2 minus secant 0 means 1. So 1 minus root 2, minus into minus plus 1. So 1 plus 1, 2. 2 minus root 2. So answer is 2 minus root 2. Is it clear to everyone? Yes or no? Shall I move to the next problem? Okay. And the third one, integral 0 to 4 mod of 2 minus x dx. These three problems are very important for IPA examination. So the third one is integral 0 to 4 mod of 2 minus x dx. To calculate this, you have to know the mod x value, mod x function value. So how it will be? Mod x is equal to x if x greater than or equal to 0. Mod x is equal to minus x if x less than 0. Okay. So here we have the function mod of 2 minus x. Mod of 2 minus x is equal to 2 minus x if 2 minus x greater than or equal to 0. That is 2 greater than or equal to x. So x less than or equal to 2. So if x less than or equal to 2, the function will become 2 minus x. Minus of 2 minus x if x greater than 2. X less than or equal to 2 minus x means x greater than 2 minus of 2 minus x. Is it clear? Okay, no problem, I will write. So if 2 minus x less than 0. So 2 less than x, so x greater than 2. So the function value is 2 minus x when x less than or equal to 2. So if x greater than 2, the function value becomes minus of 2 minus x. You have to remember this. Okay, already we have learned one property. What it is? Integral a to b f of x dx can be written as integral a to c f of x dx plus integral c to a f of x dx, where c is any one of the point in the interval a comma b. So here I am taking that point as 2. Why? Because at 2 here the function has two values. No, if x less than or equal to 2, the function value is 2 minus x. X greater than 2, the function value is minus of 2 minus x. That's why I am using the property integral a to b f of x dx equal to integral a to c f of x dx plus integral c to a f of x dx. So 0 to 2 mod of 2 minus x dx plus integral 2 to 4 mod of 2 minus x dx. Can I write like this? Yes or no? Yes, we can write. So why? Because 2 is the point which lies between 0 and 4, no? Okay. Now, here the x limits are 0 to 2. So x value lies between 0 and 2. That means less than 2. X less than 2 means what is the value? Function value is 2 minus x. Integral 0 to 2 minus x dx plus integral 2 to 4. So here the x value lies between 2 and 4. So that means greater than 2. So x value is greater than 2 means the function value is minus of 2 minus x. Minus of 2 minus x dx. Is it clear? So x greater than 2 means the function value becomes minus of 2 minus x. If x value is less than 2, we have to take function as 2 minus x. Now I am doing the integration. So integration for 2 means 2 into x. Integration of x means x square by 2. 0 to 2. Plus into minus, minus. 2 into integral 1 means x. Integral x means x square by 2. 2 to 4. Okay, now I am substituting the limits. 2 into 2 minus 2 square by 2. So I have substituted upper limit. Next lower limit. 2 into 0 minus 0 square by 2. So first part is over. Minus, and second one. Here the upper limit is 4. 2 into 4 minus 4 square by 2. Minus lower limit. 2 into 2 minus 2 square by 2. Is it clear? So after finding the integration, I have substituted the limits. So 2 2s are 4, and 4 by 2 means, can I write 2 directly? 4 by 2, 2 square means 4, 4 by 2 means 2, minus 0 into something 0, 0 by something is 0, minus 2 4s are 8. Here 4 square is there, 4 square means 16, 16 by 2 means 8. I am writing directly, minus 2 2s are 4, 2 square means 4, 4 by 2 means 2. So 4 minus 2 means 2, 0, minus 8 minus 8 means 0, minus of 4 minus 2 means 2. Minus into minus plus, 2 plus 2 is equal to 4. So here the answer is 4. Like this we have to evaluate integrals. So the function is in modulus form. So first you have to know mod x value. So if you don't know the mod x value, it is very difficult to solve the problem. Mod x can be written as x if x greater than or equal to 0, minus x if x less than 0. Okay. So this problem is also very important for IPA. Okay. Now I am moving to MSEC questions. So first question. Integral 0 to pi by 2 sin x plus cos x by 2x dx. So options are 0, 2, 4, D, none. So this is our question. So here the function is a trigonometric functions, no? So we should be very careful. So we have to know all trigonometric formulas. Then only we can do this problem. See how I am solving this. Integral 0 to pi by 2 sin x plus cos x whole square by under root of 1 plus sin 2x, I have written the question, equal to integral 0 to pi by 2 sin x plus cos x whole square by 1. Can I write 1 as cos square x plus sin square x from trigonometric identities? So cos square theta plus sin square theta is equal to 1. So I am using that formula here. So sin square x plus cos square x plus sin 2x. In trigonometry, multiple and submultiple angles, we have formula sin 2 theta is equal to 2 sin theta cos theta. So I am using this formula. So in place of sin 2x, I am writing 2 sin x cos x. Cos x dx. Integral 0 to pi by 2 sin x plus cos x whole square by under root of. So a square plus b square plus 2ab. So we can write a plus b whole square. So sin x plus cos x whole square dx. So square root get cancelled. Integral 0 to pi by 4 sin x plus cos x whole square by sin x plus cos x dx. Sin x plus cos x get cancelled. Integral 0 to pi by 4 sin x plus cos x dx. So we know integration sin x and integration cos x. No? So integral sin x minus cos x plus integral cos x sin x 0 to pi by 4. Now we have to substitute the limits. After substituting the limits, we can get the answer. Minus cos pi by 4 plus sin pi by 4 minus cos 0 plus sin 0. Cos pi by 4 means 1 by root 2, sin pi by 4 means 1 by root 2, cos 0 means 1, sin 0 means 0. So upper limit is pi by 4 minus cos pi by 4, here minus cos 0, minus into minus plus, so answer is 1. So what I did here, in place of 1 I have written sin square x plus cos square x. Sin 2x means sin 2 sin x cos x, a square plus b square. I'm sorry. So here the limit is 5 by 2, no, I forgot to write. So here here the limits are 0 to pi by 2, no, so I have taken pi by 4, so pi by 2, pi by 2, so pi by 2, pi by 2. So cos pi by 2 means minus 1, sin pi by 2, cos pi by 2 0, sin pi by 2 1, minus of cos 0 1, sin 0 0. 1 plus 1 is equal to 2, 2 is the answer. So this is the answer for this question. So remember one thing, while doing the problem you should be very careful. So unfortunately I have written here 0 to pi by 2 as 0 to pi by 4. Okay, so this is the final answer for this question. Okay, so a square plus b square plus 2ab, so I have written a plus b whole square, square root get cancelled, here I got sin x plus cos x, sin x plus cos x, and here sin x plus cos x get cancelled, so sin x plus cos x is there, then apply the integration and substitute the limits, you will get the answer. Is it clear? And I am going to do the one more question. This is also MSET bit. Integral 0 to 16 root x by 1 plus root x dx. Root x by 1 plus root x dx. Listen, here to evaluate this integral I am using substitution method. So I am taking 1 plus root x as t. 1 plus root x as t. From this we can write root x is equal to t minus 1. Differentiate with respect to x both sides. Root x derivative is 1 by 2 root x into dx. Derivative of t means dt. Derivative of constant 0. Dx is equal to 2 into root x dt. So from this, so already here we know root x is equal to what? T minus 1. I am substituting in place of root x t minus 1. 2 into t minus 1 dt. So what I did here, I have taken 1 plus root x as t. I am using substitution method. So here these limits are 0 to 16 limits for x. So we have to change the limits also. So here the lower limit is 0, upper limit is 16. So first I am substituting the lower limit, x is equal to 0, t is equal to 1 plus root 0, t is equal to 1. And x is equal to 16, then t is equal to 1 plus root 16. So 1 plus root 16 means 4, so t is equal to 5. So here the t limits are 1 to 5. Integral t limits are 1 to 5. Root x means we can write t minus 1 by 1 plus root x, we have taken it as t, and dx is equal to what? 2 into dx is equal to 2 into t minus 1 into dt. Okay. So 2 is the constant I am writing outside. Integral 1 to 5 t minus 1 into t minus 1 whole square by t dt. So it is in the form of a minus b whole square, a square plus b square minus 2ab. 2 into integral 1 to 5 t square plus 1 minus 2t by t. So I am splitting like this, t square by t plus 1 by t minus 2t by t. I already explained, a plus b by c can be written as a by c plus b by c. So like that I have written this like this, t square by t plus 1 by t minus 2t by t. 2 into integral 1 to 5 t get cancelled, t will be there, plus 1 by t minus t get cancelled, 2 dt. 2 into, so integration of t, integration of x is integration of x power n dx is equal to what? X power n plus 1 by n plus 1 plus c. So I am applying the same formula here. Integral t means t power 1 plus 1. So t square by 2 plus integral 1 by x dx. Integral 1 by x dx is equal to log x plus t. So integral 1 by t means log t minus 2 into integral 1 means t. So I have completed integration. Now I am substituting the limits. So 5 square by 2 plus log 5 minus 2 into 5. Substituted upper limit minus lower limit. 0 square by 2, sorry. So lower limit is 1. 1 square by 2 plus log 1 minus 2 into 1. So 5 square means 25, 25 by 2 plus log 5 minus 5 2s are 10. Minus 1 by 2, log 1 is equal to 0, 2 into 1 means 2. 2 into 25 by 2 minus 10. 25 by 2 minus 10 means, so it is 5 by 2. So 5 by 2 plus log 5 minus 1 by 2 minus 2. So that is equal to minus of 3 by 2. So 2 into 5 by 2 plus log 5 minus into minus plus 3 by 2. Here I am writing the final answer. So 2 into 5 by 2 plus 3 by 2 means 8 by 2 plus log 5. So 8 plus 2 log 5. So this is the answer for the question. Is it clear? So this is the MCET question. Is it clear to everyone? Okay, moving to the next question. Integral 0 to pi by 2 e power sin square x into sin 2x dx. E power sin square x into sin 2x dx. Listen. So here also I am using the substitution method to evaluate this definite. What methods we have learnt in our indefinite integration, we can apply those methods here also to evaluate definite integrations. So I am taking here sin square x as a t. Sin square x is equal to t. I am differentiating with respect to x both sides. 2 into sin x and the derivative of sin x cos x dx is equal to dt. So 2 sin x cos x means sin 2x. So sin 2x dx. Whenever you find sin 2x dx, you can directly substitute dt. Is it clear? Okay. Now I am substituting the limits. So we have to find the t limits also now. So here the lower limit is 0. X is equal to 0. T equal to sin square 0. In place of x, I am substituting 0. So sin 0, 0. So x 0 means t also equal to 0. And x is equal to pi by 2. Sin square pi by 2, sin 90 degrees is equal to 1. Limits are 0 to 1. So integral 0 to pi by 2 e power sin square x sin 2x dx is equal to integral. Lower limit 0 and upper limit is 1 e power sin square x. Sin square x is equal to what? T. E power t, and I already told you, whenever you get sin 2x into dx, you can directly substitute dt. So in indefinite integration, we have a formula: integral e power x dx is equal to e power x plus c. I am using this formula here. So e power t is the answer for integration 0 to t. And I am substituting limits: e power 1 minus e power 0. E power 1 means e power 0 means 1. So answer is e minus 1. Like this we have to solve the questions. So last 3 questions are based on MCET. So we can get this type of questions in MCET on basics, basic properties. And in 2024 we got this question. 2024 MCET, integral 0 to 1 under root of 2 plus x by 2 minus x dx. Integral 0 to 1 under root of 2 plus x by 2 minus x dx. So in TGTWREIS set we got this question 2024. So we can do this problem in different ways. You can use substitution method or you can do directly also. Okay. So first I will do it by substitution method. First I am taking x is equal to 2 sin theta. X is equal to what? 2 sin theta. So dx is equal to 2 into sin theta derivative. Cos theta into d theta. Now we have to find the limits of theta. So x is equal to 0 is the lower limit. So 2 sin theta equal to 0. Sin theta equal to 0. So theta equal to 0. The limits of theta, first one lower limit is 0 and moving to upper limit, x is equal to 1. 2 sin theta is equal to 1. Sin theta is equal to 1 by 2. So theta is equal to, x is equal to 1. So 2 sin theta is equal to 1. Sin theta is equal to 1 by 2. Theta is equal to pi by 6. 30 degrees. Is it clear? Okay. Now I am substituting integral 0 to 1 under root of 2 plus x by 2 minus x dx is equal to integral 0 to 1 under root of 2 plus 2 sin x by 2 minus 2, So x is equal to what? Sin theta now. We have to write sin theta. 2 plus 2 sin theta by 2 minus 2 sin theta d theta. Integral 0 to 1, 0 to pi by 6. Why? Because theta limits are pi by 6, 0 to pi by 6. So I am taking 2 common, 1 plus sin theta, 1 minus sin theta. So dx is equal to 2 cos theta d theta. So 2 get cancelled. So here 2 is there, 2 is constant. I am writing outside. 0 to pi by 6. 1 plus sin theta by 1 minus sin theta. So I am rationalizing the denominator. 1 plus sin theta by 1 plus sin theta into cos theta d theta. 2 into integral 0 to pi by 6 under root of 1 plus sin theta into 1 plus sin theta, 1 plus sin theta whole square. A plus b into a minus b is a square minus b square. So 1 minus sin square theta into cos theta d theta. 2 into integral 0 to pi by 6 under root of 1 plus sin theta whole square. 1 minus sin square theta means cos square theta into cos theta d theta. So by trigonometric identities we can write 1 minus sin square theta as cos square theta. So 2 into integral 0 to pi by 6. So square root get cancelled. We can write it as 1 plus sin theta. So square root get cancelled. It is cos theta d theta. Cos theta get cancelled. 2 into integral 1 means theta plus integral sin theta minus cos theta 0 to pi by 6. So now we have to substitute the limits. So 2 into first upper limit pi by 6 minus cos pi by 6. Lower limit 0 minus cos 0. 2 into pi by 6. Cos 30. Cos 30 is equal to root 3 by 2 minus 0 minus 1. 2 into pi by 6 minus root 3 by 2 minus into minus plus 1. So this is the answer for the question. Is it clear to everyone? So listen, this type of questions are coming in EAP set, so we cannot follow the same procedures. So we need to think in a different way. So 2 plus x by 2 minus x, if you want you can do it directly also by multiplying and dividing with 2 plus x also. So 2 plus x by 2 plus x we can get easily. So like this, integral 2 plus x by 2 minus x. So multiply and divide with 2 plus x. So 2 plus x whole square means 2 plus x. In the denominator we can get 4 minus x square. So 2 by under root 4 minus x square. Integral 1 by under root of a square minus x square formula we can use. And plus x by under root of 4 minus x square means integral f dash x by root f of x formula we can use. Okay, by using this method also we can get the answer. Okay. And JEE means integral 0 to pi by 2 under root of 1 plus sin x dx. So answers are A equal to 1, B is equal to 1 by 2, C is equal to 2, D is equal to 3. Not exactly, you can get this type of questions in all competitive exams like MCET or JEE anyway. So I got this question, somewhere I found it. So integral 0 to pi by 2 under root of 1 plus sin x dx. Under root of 1 plus sin x dx. Integral 0 to pi by 2 under root of so 1 can be written as by trigonometric identities. We can write it as cos square x by 2 plus sin square x by 2. Cos square theta plus sin square theta is equal to 1 now, like that. Plus sin x, multiple angles, submultiple angles. From that we can write sin x as 2 sin x by 2 into cos x by 2. 2 sin x by 2 into cos x by 2 dx. So integral 0 to pi by 2 under root of a square plus b square plus 2ab. We can write it as cos x by 2 plus sin x by 2 whole square dx. Square root get cancelled. So integral 0 to pi by 2 cos x by 2 plus sin x by 2 dx. So integral cos ax sin ax by a, cos x by 2 by 1 by 2 plus so cos sin x by 2 by 1 by 2 and sin ax minus cos ax by a. 0 to pi by 2. Now substitute the limits. So I am taking 1 by 2 in the numerator side. 2 into sin pi by 2 by 2 means pi by 4. Plus into minus, minus 2 into cos pi by 4. So I have substituted upper limit. Minus sin 0, 0. Minus cos 0, 1. By 1 by 2. 2 into 1 by root 2, 2 into 1 by root 2 minus 2. So minus into minus plus 2. 2 is the answer for this question. Okay, so this is the one of the question from JEE. And one more question. Integral 0 to k, integral 0 to k cos x by 1 plus sin square x dx is equal to pi by 4. Integral 0 to k cos x by 1 plus sin square x dx is equal to pi by 4. Then find the value of k. Answers are A is 1, B pi by 4, C pi by 2, pi by 6. Okay, here we need to find the k value. We know the integration value is pi by 4. So integral 0 to k cos x by 1 plus sin square x dx is equal to pi by 4. So here also I am using the substitution method. I am taking sin x as t. Sin x as t, derivative of sin x. Cos x dx equal to dt. Whenever you get cos x dx, you can substitute dt. Okay, now change the limits. X is equal to 0, then t equal to sin 0, t equal to 0. X is equal to k, so t is equal to sin k. So upper limit is sin k, lower limit is 0. Integral 0 to sin k cos x dx. So in place of cos x dx we can write dt by 1 plus sin x means t square, 1 plus t square equal to pi by 4. So in indefinite integration we have the formula integral 1 by 1 plus x square dx is equal to tan inverse x. So I am using this formula here. So tan inverse of t 0 to sin k equal to pi by 4. Now I am substituting upper limit and lower limit. Tan inverse of sin k minus tan inverse of 0 equal to pi by 4. So tan inverse of sin k I am writing as it is minus tan inverse of 0 means we know tan 0 0 equal to pi by 4. So tan inverse of, finally we got tan inverse of sin k is equal to pi by 4. So I am taking tan inverse to that side. So sin k is equal to tan pi by 4. So sin k is equal to tan pi by 4 is equal to 1. Tan 45 degrees is 1. So sin k is equal to 1. Sin k is equal to sin 90 degrees. Sin 90 1. So k is equal to pi by 2. So answer is. So like this we have to do the problems. Okay, is it clear? And one more problem is there. This is based on indefinite integration. Integral 0 to 2 pi e power ax into cos bx dx. So options are a by a square plus b square into e power 2a pi minus 1 b by a square plus b square into e power 2a pi minus 1 a by a square plus b square and b by a square plus b square. So already in indefinite integration we did this formula now, integral e power ax cos bx dx is equal to e power ax by a square plus b square a into cos bx plus b into sin bx. So already we proved this in indefinite integration. Now I am using the same formula here. Integral 0 to 2 pi e power ax into cos bx dx is equal to e power ax by a square plus b square a into cos bx plus b into sin bx 0 to 2 pi. Now we have to substitute the limits. Upper limit is 2 pi e power 2a pi by a square plus b square a into cos 2 pi b plus b into sin 2 pi b. So upper limit is over. Now I am substituting lower limit. e power a into 0 means 0 by a square plus b square, a into cos 0 plus b into sin 0, e power 2a pi by a square plus b square, a into, already we know cos n pi is equal to minus 1 whole power n. So cos 2 pi is equal to 1, cos 4 pi is equal to 1, cos 6 pi is equal to 1. So even is always equal to 1, plus sin n pi. We know sin n pi is always equal to 0, minus e power 0 means 1. E power 0 means 1 by a square plus b square, a into cos 0 1, a into cos 0 1 plus b into sin 0 0. So a into e power 2a pi by a square plus b square minus a by a square plus b square. So the final answer is a into e power 2a pi minus 1 by a square plus b square. So this is the right answer for this question. Okay, so based on those three properties and based on indefinite integration methods, I have did all these problems. Okay, moving to the next property. This is also called King's rule and very important. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This is King's rule. This is very important. We can use this property in many problems. Now I am going to prove this. For proving this, I am taking RHS first. What is RHS? Integral 0 to a f of a minus x dx. Okay, so here I am taking substitution method. I am taking a minus x as t. So differentiate with respect to x both sides. Derivative of a 0, derivative of x 1. So I am writing directly dx is equal to dt. So dx is equal to minus dt. Now limits. X is equal to 0. T is equal to a minus 0. So t is equal to a. X is equal to a. T is equal to a minus a, t equal to 0. So here the lower limit is a and upper limit is 0. Integral 0 to a f of a minus x dx is equal to integral a to 0 f of t into minus dt. So limits must be 0 to a now, so small to big. So what I am doing means I am interchanging the limits. Already I explained the second property. So I am using that property minus of integral 0 to a f of t into minus dt. Minus get cancelled. So the first property I explained, integral a to b f of x dx is equal to integral a to b f of t dt. From that we can write integral 0 to a f of x dx. So LHS is equal to RHS. So it is proved. So this rule is very important, King's rule. So we can use this rule in many problems. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This is the proof for that. So now I am going to solve one question based on this rule. This problem is important for IPE also. You will get 7-mark question. Integral sin x by root sin x by root sin x plus root cos x dx. Integral 0 to pi by 2 root sin x by root sin x plus root cos x dx. So for solving this problem, I am using the King's rule. What it is? Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Here in place of a, what we have? Pi by 2. Integral, first I am considering the given integration as I. First I am considering the given integration as I. Let I is equal to the given integration. Integral 0 to pi by 2 sine of a minus x. A minus x means pi by 2 minus x. Sine of pi by 2 minus x by under root of sine of pi by 2 minus x plus root of cos pi by 2 minus x dx. So I am considering the first one given problem as I, and that is equation 1. So I applied King's rule, that is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x. Here in place of a we have pi by 2, no? So I have substituted pi by 2. So sine of pi by 2 minus x by under root of sine of pi by 2 minus x plus under root of cos of pi by 2 minus x. Integral 0 to pi by 2 under root of sine 90 minus theta. Sine 90 minus theta is equal to cos theta. So sine of pi by 2 minus x can be written as cos x. Root of cos x by under root of cos x plus root of cos 90 minus theta. So cos 90 minus theta is equal to sin theta sin x dx. So I am considering this is the equation. Now adding 1 and 2. So 1 plus 2. I plus I is equal to integral 0 to pi by 2 root of sin x by root sin x plus root cos x dx plus integral 0 to pi by 2 root cos x by root cos x plus root sin x dx. So what did you observe here? Here both the limits have same limits, 0 to pi by 2, 0 to pi by 2, both are the x limits. So I am writing like this. 2I is equal to integral 0 to pi by 2 root of sin x plus root of cos x. In the denominator we have same now. So root sin x plus root cos x dx. So root sin x plus root cos x, root sin x plus root cos x get cancelled. So 2I is equal to integral 0 to pi by 2 1 dx. So 2I is equal to x. Integral 1 means x only, no? 0 to pi by 2. So 2I is equal to pi by 2 minus 0. So 2I is equal to pi by 2. I is equal to pi by 2 into 2. So pi by 4. So pi by 4 is the answer. So this is a 7-mark question. So you will get this question in IP. Is it clear? So, and we can do this problem by using small technique. So here we have, so the question is this, no, integral 0 to pi by 2 root of sin x by root of sin x plus root of cos x dx. This is the question. So whenever you get the problems of like this, integral 0 to a f of x by f of x plus f of a minus x dx. If you get any problems of like this, you can use direct formula. So a by 2. So here the function is f of x. F of x is equal to what? Root sin x. Root sin x, root sin x is there, plus root of pi by 2, pi by 2 cos pi by 2 minus x. Sorry, sin pi by 2 minus x is cos x, no? So we can apply this formula to this problem. So answer is pi by 2 by 2, so pi by 4. So we can get directly answer without doing the total procedure. So here I want to tell one thing. So as per my knowledge, I have explained all this. So if you get any doubts or anything, you can contact me. So thank you everyone. Have a nice day.
Ask questions.
If you have any questions, contact the number.
So if you have any questions, contact the following number. So 7337. Over. I can.
They will call, you clarify the doubts, we close. 5 minutes.
వాళ్ళు స్క్రోల్ నెంబర్ మీద మీకు డౌట్ ఒక కాల్ చేస్తారు మీరు డౌట్ చెప్పాలి.
Okay, so if you have any doubts, you can contact the following number. So thank you everyone. Have a nice day.